the tropical rainforest, a sauna of life. Here, the temperature on the forest floor can soar.
But for the leafcutter ant, this heat is just another obstacle. She is a worker, a transporter, in an endless supply chain.
Millions of sisters, a river of green, flowing toward a single destination.
The mound, a megalopolis built of clay, home to 5 million souls. Carbon dioxide, heavier than air, sinks to the bottom. It pools in the chambers, a toxic trap. And here, the heart of the colony, the fungus garden. It breathes. Living underground produces immense heat, enough to cook the colony from the inside out. So, how do they survive? The queen, the engine of the colony. Her metabolism alone generates a constant burning fever. And deep below, the waste chambers, decaying matter composting in the dark, releasing heat and deadly gases. Heat rises. It's simple physics. The hot, stale air seeks an escape. To harness this heat, the ants have built a chimney. But heat alone isn't enough. They need an external power source. The wind.
As wind strikes the tall turret, it is forced to move faster over the opening.
Bernoulli's principle. Faster air creates lower pressure. A vacuum is formed. This vacuum pulls the stale, toxic air out of the colony. The nest exhales.
Fresh, cool oxygen is drawn in through the lower vents. A passive, zero-energy air conditioning system.
Fresh, cool oxygen is drawn in through the lower vents. A passive, zero-energy air conditioning system. When the crowd thickens, the air turns stale. Carbon dioxide levels spike to dangerous highs. When the crowd thickens, the air turns stale. Carbon dioxide levels spike to dangerous highs. To control this, they use their own bodies. This soldier is a living valve. By blocking the entrance, she stops the airflow. A biological plug regulating the colony's breath.
The fungus is picky. It demands 80% humidity. 1 degree of change, and the food source dies.
Despite the scorching jungle sun above, the temperature down here stays perfectly stable. While the soldiers manage the air, the waste crew descends. Deep into the colony's basement. The rotting waste generates heat. This rising hot air pushes the circulation system from below. A convection engine, powered by the sun, the wind, and their own waste.
The pressure drops. The ants feel the weight of the air changing instantly.
The pressure drops. The ants feel the weight of the air changing instantly. Stridulation, a high-pitched scream sent through the ground. Close the gates! Chaos? No. This is a synchronized emergency protocol.
They drop their food. They pick up stones, twigs, and wet clay. They are building barricades.
The first drop falls, like a bomb on the colony doorstep.
At this scale, water is not liquid. It is a sticky, heavy glue that can trap them instantly.
The great chimneys must be sealed. If water enters the main shaft, the colony drowns.
They mix soil with saliva to create a waterproof mortar, stronger than concrete relative to their size.
Sealed. The ventilation is cut. The oxygen clock starts ticking.
Outside, the storm rages. Inside, a terrifying silence. The passive wind engine is dead. With no airflow, the colony's breath becomes its poison. Carbon dioxide levels climb vertically. The queen, with her massive metabolism, is the first to feel the choke. She is gasping for air. The fungus garden, the city's lung and stomach, begins to suffocate. If it dies, the colony starves.
But 50 million years of evolution has a backup plan. Active ventilation.
She begins to pump, telescoping her abdomen, squeezing her internal organs.
Through tiny valves called spiracles, she forcibly expels CO2 and sucks in whatever oxygen remains.
It's not just breathing, it's mixing. She becomes a living fan, churning the stagnant air.
1 becomes 10. 10 becomes 10,000. A synchronized biological ventilation system.
Hours pass. The air is thick. The work is exhausting. But they cannot stop until the storm breaks.
The little gatekeeper senses the change. The danger has passed.
With a collective heave, they unseal the chimney. The heavy stone is pushed aside.
The pressure releases. Stale, hot gas shoots out of the chimney like a geyser.
The active pumping stops. Physics takes over once again. The chimney effect is restored. Deep in the royal chamber, the queen takes her first breath of fresh air. The crisis is over. The fungus garden drinks the fresh humidity. It survives. The city's food source is secure. Carbon dioxide levels plummet. Oxygen saturates the tunnels. The system works. But the storm has left its mark. The repair crews are already at work, rebuilding the eroded towers. As night falls, the forest cools. And with the temperature drop, a new challenge arises.
At night, the wind often dies down. The external power source for the ventilation is gone.
But the colony remains a hot engine. The temperature difference between inside and outside is now at its peak. Buoyancy takes over. Hot air is less dense. It rises naturally, creating a powerful updraft called the stack effect. But the city is growing. A mature colony houses 5 million ants. They need more space and more air. To expand, they must dig. Each worker removes a piece of earth 50 times her own weight. A logistic marvel. A bucket brigade moving tons of soil from the deep to the surface. And the walls are not solid. They are porous. A lattice that catches even the slightest breeze. And the walls are not solid. They are porous. A lattice that catches even the slightest breeze. And the walls are not solid. They are porous. A lattice that catches even the slightest breeze. A masterpiece of civil engineering. Built by the blind, in the dark, without a blueprint.
Dawn. The air is heavy with moisture. Too much humidity can rot the fungus garden instantly.
Every morning, the maintenance crew clears the intake valves. The system must breathe. But an open door invites unwanted guests. The phorid fly, a nightmare for the colony. The defense, a tiny sister, a minima hitchhiker, riding shotgun to fight off the air raids. The defense, a tiny sister, a minima hitchhiker, riding shotgun to fight off the air raids. At the main vents, heavy soldiers stand guard. Only the colony scent allows passage. The tunnel itself is a trap. It doesn't go straight down. It curves, an S-shaped design. Air flows around corners easily, but heavier predators and debris crash into the walls. A passive momentum filter. But what about water? Even with the covers, heavy rain can breach the defenses.
They dig sumps, deep, dead-end chambers at the lowest point. The water drains here, far from the precious fungus.
And here is the genius. They place the heat-generating waste at the very bottom. Why? And here is the genius. They place the heat-generating waste at the very bottom. Why? And here is the genius. They place the heat-generating waste at the very bottom. Why? Because heat rises. The garbage dump is the engine. The waste powers the air conditioning. Compare this to our own hives. Glass towers. Sealed boxes fighting against the sun. We pump massive amounts of electricity to cool our buildings, fighting physics instead of using it. The colony achieves total climate control with zero electricity, powered only by geometry and the sun.
Architects are finally looking down. Biomimicry. Copying nature's blueprints to build better cities.
Est-ce que vous savez comment faire la quiche lorraine?
¿Sabes qué? No.
This is not a city of individuals. It is a superorganism, one single being with 5 million cells.
The air they breathe today ensures the life of the next generation born tomorrow. The pumps may stop, but the colony never sleeps. The flow of energy and air is constant.
Their ventilation is also their shield. The constant updraft keeps airborne enemies at bay. Physics, chemistry, architecture, biology, all woven into the soil beneath our feet. We look to the stars for advanced technology. Perhaps we should look down instead. The engineers of air. Tiny masters of a hidden universe. Breathing in and breathing out. The lungs of the earth. In the world of the leafcutter, survival is just a breath away.